everybody, it's Math at Home here. This is our fourth lesson today. In this video, we're going to cover page 160. This part includes two individual parts to be covered. The first one is about to be a practice part related to the symmetric situation, and the second part is about nets. But in order to arrange it in the best way possible, I will first start with teaching nets, then we will go to the practice part about the symmetry. Let's get it started. In order to get familiar with nets, first we need to define and understand what the meaning of the net is. So nets are a two-dimensional, which means 2D, or a flat pattern of a polygon that could be folded to form a three-dimensional shape. In simple words, if you want to make a cube, for example, out of a paper, you first draw the net of a cube on a piece of paper using scissors, cut it out. Now, before you fold to make the cube itself, the 2D shape, which is made of the paper, the opened, unfolded form, is going to be called net of the cube. So as an example, if you want to determine what the net of the pyramid is, if I want to open this pyramid, I will have a square as the base of the pyramid and four triangles as they're going to be their outer faces of the pyramid. Now, in order to further understand about the nets of different 3D shapes, I'm going to show you another video which is about opening the 3D shapes into their nets and closing them all over again. So it's going to help you out in order to have a good understanding of what nets are. Let's watch the video. Okay, so here you can see different kinds of 3D shapes. Something related to triangles, let's say this pyramid. Let's go for the right-angled base one. Yes, here it is. Okay. So here if I want to open the net of the 3D shape, you will notice that the net is exactly a 2D shape. It means if you look at it from the side, it looks like a piece of paper. So we're going to have one equilateral triangle and three right-angled triangles that if you fold them in the correct way possible, you're going to have the 3D shape right after you close the net. So let's go for something a little bit different and go for the cylinder part. Now, cylinder is one of the shapes that is mostly interested me. Now you could see that we have two bases. They are circles, and the shape surrounding it is going to be something very surprising once I open the net. Here we go. Exactly now. As you can see, we're going to have two circles and one rectangle. Actually, the shape which covers surrounding part of it, all around the shape, is a rectangle. And two circles are going to form the top and the bottom of the cylinder. Now, once we close it, we're going to have our previous 3D form of cylinder. Let's talk about the cone. The cone here is very interesting, actually. Some people think that it includes a circle and a triangle, which they are wrong. This is very much interesting. I love this shape. Once I open it, you will notice that, yeah, this is the upper perspective of the shape. Once I open it, you will notice that the bottom was already a circle and the top part of it is somehow close to a semicircle. It's not a full semicircle, it's a little bit closer, shorter. And if you could, yeah, exactly, that was the point. So nets are obviously some 2D shapes, 2D plots. So once you look at them from the side view, you will notice that it looks like a piece of paper, no depth. So these were some more examples from the 3D shapes. Let's get back to our video and continue with the practice part. Okay, right now that you're done with the video, all the things about nets is almost covered. So let's go to the practice part on page 160. Practice part on page 160, question number 1. Use a squared paper or a pegboard to make the second pattern on page 159. So as you remember, we had a pattern on page 159 which was not symmetric. Now choice A says, add one more square or peg to make the pattern symmetrical. How many lines of symmetry does the pattern have? Now I give you 1 minute to think about it. Okay, so obviously if we add actually there is one lacking part that if at the first glance that you look at the pattern, you will notice that you need one more square to make the pattern symmetrical. And if we want to talk about the line of the symmetry, it's going to be vertical. So the right part is going to be exactly same as the left part. What about the horizontal line of symmetry? Well, unfortunately, no, because the upper section is not going to be the same as the bottom section. Part B says, add two more squares or pegs so that the pattern has two lines of symmetry. Okay, in addition to the single square that we added before, now you're going to add two more squares. It means in total we're going to have three more squares in the pattern. Please think it out and make the shape and add the squares in a way that we have two lines of symmetry. Okay, so obviously by adding the single square to the center of the shape and two others to make the bottom line of the shape complete, we're going to have two lines of symmetry. One of them is going to be the vertical one, which divides the shape into two identical parts on the right and the left. And if we turn it into a horizontal form, our shape is going to have two similar parts in the upper and bottom section also. Choice C says, add another four squares or pegs so that the pattern has two lines of symmetry. Think about it, please. We do not want to have more than two lines of symmetry, only two. So in total, you're going to add 7 squares. Think about it. All right. So actually we're going to have our first three squares at this previous places. In my opinion, we would better place the squares as I represent it now, so that our shape is going to have one symmetrical line, which is going to be vertical. Now, as you can see, the right and the left part are identically same, and one horizontal symmetrical line. Now, we don't have any diagonal symmetrical situation here, so in total, we're going to have two symmetrical situations. Question number 2. Use squared paper or a pegboard to make a pattern each time that has no lines of symmetry, one line of symmetry, two lines of symmetry, and four lines of symmetry. Actually, here I'm pretty much interested to see your own answers. I want to see what shapes you're coming up with. So I give you some time to think about all four choices. Then I will represent my own personal answers. Go for it. Okay, so as an answer for A, I would prefer having a trapezium. For B, because in a trapezium there is no symmetrical situation. Either you want to have your lines diagonally or vertically or horizontally. Neither part of the shape is going to cover the other. So no symmetrical situation. For part B, one line of symmetry. Actually, I could come up with an isosceles triangle, which in this case, I'm going to have one vertical line of symmetry, which means the right and the left parts are going to cover each other. C, two lines of symmetry. My answer is going to be a rectangle, a simple rectangle for it, because a rectangle doesn't have diagonal symmetrical situation, only the vertical, which divides the shape into two equal pieces on the right and left, and the horizontal one is going to do the same thing for upper and the bottom section. Part D, however, with four lines of symmetry, is going to have, we're going to have a square, which in this case we have two vertical and horizontal symmetrical lines and two diagonal symmetrical situations. So in total, we're going to have four lines of symmetry. Thank you very much for watching this video today. See you with another video. Bye bye.